Hi everyone, for this part we're going to finish up the review for lesson 3 about congruent triangles and lesson 4 about triangle proof. So again, I'm going to just kind of select ones as I go. I might not do all of them, but just highlight some of the important parts. So first thing here, we talked about triangle congruence. When they give us a congruent statement, the order is very important. So for example, A, we know, lines up with G, L lines up with I, and X lines up with W because of the specific order that they fall in. So if it helps, label them by underline, circle, boxing, something like that to distinguish based on which angles line up. So for example, if I'm talking about LX, I'm going from the circle to the square, circle to the square. That means LX is the same as IW, which must be 4 based on what's given to us. Angle I, this is a good question because angle I is congruent to angle L because they're the same circles. Angle A is congruent to angle G. Now this is where it gets a little bit different. The measure of angle I, meaning what is the value? Okay, so the difference between 2 and 4 is that this one is looking for what's the same angle. This one's actually saying what's the measure? What is the actual angle it's equal to? So I don't have enough in the triangle right now, but we know that X and W are the same. So if X is 92, W is 92. And therefore, I know that since all three angles add up to be 180, I must be a total of 33 degrees. IW, if I look at that, is the same length as LX, which we found out was 4. And then finally, triangle LAX. Again, order is important here. So circle to underline to square. IGW would be the correct triangle. So the order is important. That's the main takeaway here. In this next one about writing congruent statements, again, I'll just show you an example. For angles, angle V is congruent to angle T because they have both double underlines, okay? I could also say in terms of side lengths that ZX, so from Z to X, has to be the same as from Y to W. Okay, so that's all that's asking for. So there's 2 more angles and there's 2 more sides that you could follow along with there. Now it's what we've been talking about with our sort of our 5 shortcuts. As a reminder, side, 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 we have all sides. Side, angle, sides, 2 sides, the angles between them. Angle, angle, side, 2 angles, and then 1 side. Angle, side, angle, 2 angles, where the side is between them, and then finally hypotenuse, leg for right triangles. So for 8, I actually, no conclusion here. I don't have enough information. I have an angle, I have a side. I need at least one more thing, and I don't have it. In number 9, I do have the reflexive side. Now, this is the one that's going to be the most complicated. When you see parallels, we've talked about this in previous chapters, this is alternate interiors. So we know that these 2 have to be equal. So we know that this has to be angle, side, angle. In number 10, now this is one where I'd actually redraw it. So I know that this length is the same as this length in this triangle. And they also give us those sort of like fixed angles in the middles. So based on redrawing them, I can say it's side, angle, side. Whenever you're not sure, you really should just redraw it. It's much easier. Even in my answer key, where I worked it out, I redrew it for myself too. Okay, number 14. So again, looking at what we know is equal, we know that B lines up with E. So if E is 42, so is B. And so I know that 42 plus 87 plus 3y has to be 180 from this triangle. And so when I can solve there, I get 3y equals 51. And so y has to be 17. X is actually nicer. Since A and D line up, I know that D has to be 5x plus 2 has to be 87. So just a quick little 2-step solve there. X is also 17. Now, looking down here, so the idea here is that in each of these, they give us some amount of information. So I'm going to draw it on mine, and then I'm going to erase it afterwards because I can do it here. D is congruent to Q. F is congruent to T. What else would I need to do side, angle, angle, side? So there's actually two answers for this one. What I do not want is DF and QT. I could do DE and QR. That is a possible solution. Or, because it's angle side, I could say EF is congruent to RT. Either one of those would work. So what it's asking us in these problems is, it's saying, if I know I want to prove it by a specific method, what other piece would I need? So let's look at the next one, 17. E again, so I can erase E is congruent to R. EF is the same as RT. What would I need for angle, side, angle? So again, let's look. Angle, side, I have that. I need the third angle in a row. So I need that F, angle F, has to be congruent to angle T in order to use angle, side, angle. All right, so I'm going to reset for the last one. And they're all, you kind of want to treat these as separate problems. D is congruent to Q, where DE is the same as QR. I want side, angle, side. So I have side to angle, side to angle, side, angle. I need the next side that comes in that order. So that would be DF has to be congruent to QT. So for 19, James says that these two triangles are corresponding angles, so they must be congruent. Well, I think it's pretty obvious that they can't be congruent because one is inside of the other, and congruent means same shape, same size. But we know that he understood that the angle measures are equal here. So we're going to call these proportional triangles. They're not congruent, they're proportional. We're going to come back to that in a later chapter. So in the statement, we know that if all the angles are the same, they're the same shape. But we can kind of scale them up and down, which means that they are proportional, not exactly equal. All right, and then finally CPCTC. So this one is just asking, basically it's kind of weird. In order to get to CPCTC, what is the method we would have to use? So based on this diagram, we know they have the reflexive side, so we would say side, angle, side. Now, the whole thing about this is, remember, CPCTC means corresponding parts of congruent triangles are congruent. Meaning, once I know two triangles are equal by one of our 5 shortcuts, then all the pieces have to be congruent. So same thing here. So I have angle, angle, side, angle, angle, side. So we know that these two are set up by angle, angle, side. Then we can say this is congruent by CPCTC. Corresponding parts of congruent triangles are congruent. And then here, this one would be just side, side, side. Okay, so 4, 5, and 6 are pretty much the same questions. I'm going to look at 5 real quick, just because I found 5 to be a little bit difficult to read. So the two triangles we want to talk about is ABD. So we know that the middle down here is going to be congruent. And we know D is going to be congruent. And then we want triangle EBC. There's actually another way to prove this by using isosceles triangles. It's actually a lot easier. But if you look here, we have angle, side, angle. Okay, that's all it really wanted us to say. It's just a little bit difficult to look at the actual drawing of the triangles for those. All right, and then on to the proofs. So again, for the proofs, we just want to use anything that we can. So remember, we start off with our statements. And then reasons. So I know that AB is congruent to CD. That's a given. There's nothing more I can do with that. They then tell me angle ADB is a right, and so is CBD are right angles. That's a given. Now, what's important here is that we can identify that this is a reflexive side. So BD is congruent to BD by the reflexive property of congruence. Now, with that information, we actually have enough to say that triangle ABD has to be congruent to triangle CDB by hypotenuse leg. This is a 90 with a hypotenuse and a leg. So we're done with the triangles. We know that the triangle is all congruent, but now to say finally that this angle has to be equal to this angle, well, that's now where CPCTC comes in. Because once we know the triangles are congruent, all the parts that correspond have to be as well. Okay, our last one. This one's be a little bit more straightforward. So we have, again, so statement, reason. We have that AB is congruent to EB. That's a given. It's marked in our diagram. And we have that angle ADB is congruent to angle ECB, which we could just say angle D and C since they're all by themselves. That's also a given. Last important thing here, we have an intersection, meaning we have vertical angles. This one we definitely have to use 3 letters for. ADB is congruent to angle EBC by vertical. So we know that triangle ADB has to be congruent to triangle ECB by angle, side. And once we have that, then anything else we want in the triangle just comes for free with our good friend CPCTT. Okay, well, I hope that was helpful. You can rewatch this and part 1 for the test preparation. And let me know if you have any questions. See ya.